Welcome to Amrita Tarang, where every voice creates a wave. Today we have with us Professor K. Ramasubramanian, Professor in Charge, Centre for Traditional Indian Knowledge and Skills, IIT Bombay. Welcome, sir. So, Indian mathematical and astronomical traditions span many centuries in regional cultures. So, from your perspective, what are the key methodological challenges in studying these traditions rigorously today?
See, when you say traditions, there are two ways to understand. One is a tradition which has to do with the way of writing. The other, a tradition which has to do with the kind of problems that they have been attempting to solve. So, in short, I would say the challenge that the current generation primarily faces is the lack of acquaintance of the knowledge as well as the style in which these traditions have been representing and transmitting the knowledge over generations. This need not necessarily be an issue with the Indian mathematical or astronomical tradition. If we see even the evolution of modern science, I don't think anybody will be able to understand the work of Newton as such. We need interpreters because he has been using certain terminologies called fluxions, etc., which nobody understands today. So, a familiarity with the phrases that these people have been employing, a familiarity with the language in which it has been written, and a familiarity with the style in which it has been composed, all the three have to be understood. For instance, in the Indian astronomical tradition, if you just look at the earliest text which we call as Vedanga Jyotisha, which is estimated to have been composed around 1400 BCE, has been written in a certain style. Those are verses only. Later, after a huge gap during which we do not have many of these texts which were prevalent available to us. So, we have Aryabhata. He has chosen the style of composing all things in the form of a meter, which is called Arya meter. Then we have a few other astronomical very important works, etc. Most of them have been written in the form of verses only. When I say verses, these are verses which have been composed in Sanskrit. So, one needs to be familiar with the Sanskrit language. Secondly, it is not necessarily the verses alone, but the technical Sanskrit. See, if you want to read Kalidasa, you have to learn certain phrases which are most employed in literary works, Sahitya. Whereas, if you want to understand these Indian astronomical works, there will be plenty of terminologies which one has to get familiar with. So, for representing numbers, for representing formulae, for presenting models, all of them have been beautifully codified in metrical verses. So, the phrases have to be familiar, the language has to be familiar, and how to make out the prose order from the verse. So, all these things are bit of a challenge, but once you familiarize with the language, that will be the first step to take. If you know English, it does not mean that you need to understand physics, right?
Yeah.
So, it has its own terminologies, acceleration, momentum, divergence, curl, and so on and so forth, field. So, these are things. So, field means, I mean, we are referring to some field, not the field elsewhere, right?
Yeah.
So, that way there will be hundreds of terminologies that have to be understood. So, familiarity with the language, familiarity with respect to the technical terms that have been employed in the language, and a reasonable proficiency for you to debug for the first time and understand.
Okay.
So, nowadays fortunately there are certain translations which are available with modern mathematical notations, and therefore it should not be a serious issue for a serious student. So, what is required is a passion to learn and a commitment to learn and a certain internal drive to understand our own scientific heritage. So, it should not be as challenging as it would have been maybe 100-200 years ago.
That is very insightful. So, manuscript studies are very central to your research. So, what are the major difficulties involved in editing, interpreting, and validating these mathematical and astronomical manuscripts? Because also there are variations across manuscripts, which I think it's very common among Kerala school texts. So, how does it affect the understanding?
Yeah, see, manuscripts are written in different scripts, they are written in different styles, and they are very crucial to understand the text. When I say the text, not necessarily the texts which have been not brought forth, even the texts which have been brought out. So, for the first time they would have got hold of only a few manuscripts. After all, manuscripts are handwritten by some scribes. It need not necessarily be scholars who may be engaging, right?
Yeah.
So, your Shishya may be asked to write a manuscript. Sometimes it is like this. So, nowadays you may not be that familiar because you yourself use computers and so on. 30-40 years ago, when the computers were not prevalent in every household, people used to go to some typesetter. That typesetter need not know. So, you write something, he will tuck 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 type something, right? So, if he commits a mistake, suppose he splits the word, okay, together, to get her, what will happen? Meaning completely changes. You don't need to change the letter, you just give a pause, gap between, it is completely gone. Similarly, in Sanskrit, suppose you leave out some dirgha, hrasva, something, then the word totally changes. So, this problem of any carelessness on the part of the scribe could literally mean completely different things. So, the challenges in today's world is deciphering the script in which it has been authored, and the style of even writing the same letter changes over a period of time. So, if you look at A, which is written today, it may be in a particular form. In those days, they would have written A in a slightly different way. So, there is evolution in the way it is written, there is variation in the style of writing from place to place at the same time. So, these manuscripts that are available to us are very crucial in trying to decipher the exact reading that is available, because one manuscript may be missing some character, another manuscript may be supplying us that particular character. So, one manuscript may jump, see the same letters, same phrases may appear. So, if for instance in English, So, suppose you say cover, the cover appears in the next sentence. From this sentence to that sentence, that fellow will jump, right?
Yeah.
In between, he would have gone for some coffee break. So, when he comes back to write, he would have lost. So, those kinds of errors, missing sentences, missing letters, so swapping letters, all these errors are possible, and these errors will completely mislead us, confuse us. Okay, we will be really worrying what this means. So, multiple manuscripts are essential, they need to be preserved for ensuring that you produce an authentic version of the text. So, I can tell with my own experience that recently we have brought out a commentary which has been written by Utpala to a very important text called Brihat Samhita. The Brihat Samhita is authored by Varahamihira in the 5th century, 6th century. So, its commentary is available, but because of a very long commentary, different scribes have made different errors. The one which was published long back could not be deciphered. See, sometimes it is because of pressure people bring out in a hurry. So, once it is brought out in a hurried manner, likely to be error. So, you may have access to only 4 or 5 manuscripts, which may not be necessarily good, one may be a copy of the other. So, you need to have multiple manuscripts copied at different points of time in order to collate the most authentic version of the text. So, familiarity with the script is essential, and this deciphering ability to understand what would be the most authentic edition is essential. When it is a metrical form, this person who edits the text should be aware of the meters, because they follow a certain rhythm. By reading itself, you will be able to see that there is an error. And the fourth thing is technical expertise in trying to decipher the subject is also essential for us to bring out authentic editions. But irrespective of which field you work, so manuscripts are essential to get the best editions, even among the printed versions of the text where there are many mistakes.
I think it's really fascinating how small details can make big differences in our interpretation of things and manuscripts in this matter. That was really helpful. So, sir, in your perspective, how important is it to study mathematical ideas within their astronomical, calendrical, and observational contexts rather than in isolation?
See, the mathematical ideas actually form the bedrock for any science. So, that is why some people say mathematics is the queen among sciences. Now, when you want to decide when you need to celebrate Ramanavami, when you need to celebrate Krishnashtami, when you need to celebrate Vishu, for instance, we need to know precisely where the positions of the sun, moon, etc. are. So, for you to say this is where the sun is, this is where the moon is, you need to have mathematical models, the rate at which these objects are moving. So, the rate at which things are moving have to be necessarily modeled. If you want to do even election prediction, you need to have some mathematical statistical model. Similarly, for calculating the positions of the planets, these mathematical models are indispensable. And since the rate at which the sun, moon, etc. are moving are non-uniform, your model has to capture the non-uniform motion of these objects. So, that is where people have been trying to build better and better and better models. So, the mathematical ideas that have been arrived at by the Kerala School of Mathematicians have been far more sophisticated compared to the mathematical ideas that were there. Ultimately, it led to even the infinite series discovery by Kerala mathematicians. After all, any astronomical problem, so since you asked how it is relevant for the study of astronomy, astronomy is essential for calculating time. You understand? How do you know a year is over? The sun coming back to the same position, or earth coming back to the same position. Okay? So, this needs a mathematical model. Same position means you can't be observing sun in the background of stars.
Right.
You need to refine over hundreds and thousands of years to arrive at it as accurately as possible. So, this is not merely observational, but it is more through computation. And the computational models have to be periodically checked with observation. So, there is a both way connection.
Yeah.
So, these mathematical ideas which have been formulated by Kerala mathematicians, particularly in planetary computations, you need to know how to precisely compute sine function, cosine function, etc. For that, they have brought out significant advances.
I think that's really impressive that we're able to do that. So, talking about Kerala School, so Kerala School texts display remarkable sophistication in error analysis and correction techniques. So, what does this tell us about their understanding of convergence and approximation?
Oh, convergence issue. Okay. Let me tell you, it is the Kerala mathematician, rather mathematicians, I would say, Madhava, about whom the conference has been organized by you, who came up with the infinite series expansion for pi. You know, pi is an irrational number. What does it mean? It means it cannot be represented as a ratio of two numbers, right?
Yeah,
What is the value of pi?
3.14.
1/4. Is it an approximate value or correct value?
It's an approximate value.
Approximate value. Suppose you tell for 10 decimal places, that will also be approximate. Even if you give 1000 places, it will be approximate. Now, this means that this number cannot be represented as ratio of two numbers. Okay. Given this, you will only write pi is approximately equal to, not equal to. You cannot put that. So, the only way that you can put equal to is to have some infinite series in the right hand side. Now, Madhava seems to have obtained this infinite series for the first time in the history of mathematics. And the verse is a very beautiful short verse. Vyase varidhinihate rupahrite vyasasagarabhihate trisharadi vishama sankhya bhaktam rinam swam pratakramat kuryat. This is the verse. Rinam swam. Rinam means in Sanskrit, classical Sanskrit, debt. Swam means my own. Actually, this represents minus and plus. So, I told you, no, you need to understand the context in which it appears, the technical terminology that is used. So, this Rinam swam prathak kuryat, he says, Vyasa. See, Vyasa means diameter in mathematics. Vyasa means you may be remembering that Purana, author Vyasa. Okay. Vyasa can also mean something which is wide, etc. Now, Vyase Varidhi Nihate. Varidhi means ocean. In the context of mathematics, it represents number 4. Varidhi means Varam Nidhi, essentially reservoir of water. So, in a mathematical text you need to understand. So, 4 times diameter, Rupa Hrite, Rupa means form, in mathematics it represents number 1. So, 4D by 1. Vyasa Sagara Bhihate, again 4D. Trisharadi Vishama Sankhya Bhaktam. 3 means 3, Shara means 5, Vishama Sankhya means odd number. So, you have 4D in the numerator, denominator is 1, 3, 5, 7 and so on. You keep on writing all odd numbers. Will it ever end? It is infinite. So, you have to sum up this infinite series. And he says Rinam Swam, minus plus minus plus minus plus. So, it is an alternating series. Okay. Now that I said the series, since your question has to do with convergence, this series is a terribly slowly converging series. So, you have essentially 4D, you remove that. Okay. So, if you write pi by 4 in the left hand side, right hand side will be 1 minus 1 by 3 plus 1 by 5 minus 1 by 7 plus 1 by 9 and so on. It is infinite series. This series is a terribly slowly converging series, which means even to get 3.14 from this, you should take at least 100 values, 100 terms in the series rather. 100 values means values of the ratios. So, to evaluate pi using this series, you have to find out brilliant techniques by which you can convert this series into fast converging series. So, the analysis has been done by Kerala mathematicians. It is really a brilliant analysis, and through that they have been able to turn this terribly slowly converging series into stupendously fast converging series, and thereby you just evaluate 50 terms, 100 terms, you will be able to get the value of pi as accurately as you want. So, with almost 50 terms itself, you will be turning this series into some other series. So, considering 50 terms in that, you can almost get 10, 11 decimal places value correctly. So, the analysis which has been done is really remarkable, and some of us who have been trained in the modern mathematics are really awestruck as to how they have been able to do this kind of analysis.
That's really innovative. So, you did emphasize the importance of internal textual evidence over retrospective interpretation. So, can you please elaborate on how historians should assess mathematical accuracy in its historical context?
Okay. See, mathematical accuracy in the historical context. This is something which is very essential for us to understand the contribution that has been made by a certain civilization. See, today you have extremely sophisticated instruments by which you will be able to make very precisely determine what is happening in the sky. Whereas with naked eye, you can only have a certain resolution that can be seen. Beyond that, it is impossible. Even today, the TV movies or any other screens are running very fast, right? It is only shot by shot, but you see as if everything is continuous. Why? Because of certain factors which we are having. Now, this resolution that the naked eye has, with that resolution, people have been able to make this amount of measurement with this accuracy is something which has to be necessarily looked through the context. So, the content without understanding the context in which it was discovered doesn't give you a clear picture. So, with today's thing, you will not be able to assess what has been done and then make a statement this is all very approximate, useless, etc. But given the tools that they possessed, when I say tools, I mean both mathematical tools as well as the other sophisticated tools with which they can measure. See, suppose you want to see something in a focused manner, so you may have to have some kind of a tube, etc., etc. So, they had made some devices for that also. So, a variety of devices have been devised by these people to enhance the accuracy with which they could do. And therefore, if one has to study the contributions made by certain civilizations in observational science, one is theoretical science. So, this pi evaluation just now we talked about has nothing to do with observation, it has to do with pure mathematics, right. On the other hand, if you want to determine the position of moon, sun, etc., or any other planet precisely, you have to necessarily correlate with observation. So, when you want to predict eclipses, you have to necessarily do. So, if this is the problem, then the context is all the more essential. Even in theoretical problems, I would say mathematics. So, the sophistication of the development in mathematics should be kept in mind. Was it a huge leap given the context? Is to be assessed only by knowing the context. See, so something may look like very simple for us today, but it is a huge leap. Even the mere representation of numbers, decimal system, for instance, you have studied Roman numerals?
Yeah.
Okay, suppose you want to write 58, how will you write? L V 111, right? L is 50, so V is 5, 111. Okay. Suppose you write 23, so you will write x 111. Suppose you have to multiply 58 into 23, how will you multiply? Assume that you do not have this notation.
Mm.
See, you have 5 symbols there, you have 5 symbols here. 57 into 23, suppose you want to put, you have 2 decimal places, 2 decimal places. You can multiply, right? 8 into 324 you will put. But with that notation, how will you put? So, the context, so this representation itself, which is so common to us, is a huge sophisticated device. So, why I said this? I said this because the context in which it has been done, the period in which it has been done, so all that matters when you look at the whole evolution of ideas.
I think it's really important that we don't take for granted things that has is quite a sophistication and remember our roots in that sense. So, what role do institutions like IIT Bombay's Centre for Traditional Indian Knowledge and Skills play in sustaining serious manuscript-based research in today's times?
Okay. See, these institutions also facilitate in a great way. One is, if you are in a certain institute where the teaching load is not too high, you will be able to focus more time on research. If you are in an institution which does not demand too much of administrative work from you, then also you will be able to devote more time. If you are an institution where the boss does not keep monitoring and then really keep annoying you, then also you will be able to have peace of mind to do research. So, that way these old and premier institutes provide a much better environment compared to other institutions which are private institutions, which will be more demanding on the faculty side. This is one aspect. The other aspect is these institutions will also be able to attract little more funds, see, by virtue of being premier institutes. That also facilitates. One is administrative facility, the other is financial facility, the third is certain flexibility. Now, the name that you had said, see, Center for Traditional Indian Knowledge and Skills. So, this is a fledgling center. Before that, so there was Center for Indian, so basically science and technology. So, that was the idea with which the center, okay, Center for Indian Science and Technology in Sanskrit. This was the earlier unit which was housed under humanities. So, this is a recent center which has come out to broaden its scope, so including skills. Earlier it was mere science and technology in Sanskrit. Now, we wanted to add. So, the general criteria which enables a researcher to do better, I explained to you earlier. Okay. Now, specifically, so this association with IIT Bombay has been a huge facilitator for me, because earlier I have worked with these universities where the bureaucracy is very difficult. Even small things you may have to go here and there, run, waste a lot of time. So, one is it is able to attract better students, it is able to provide you much better facility, it is also enabling you to devote more time to research, and the research publications will also be better honored, see, respected. So, all these are playing a crucial role in a researcher being far more productive.
I see. So, when multiple computational procedures are presented for the same astronomical problem, how did traditional scholars decide what method to accept?
Okay. See, when there are different procedures available, suppose I ask you, when there are multiple routes to reach Trivandrum, which route will you choose?
The shorter and most comfortable route.
Comfortable is one thing.
Yeah.
Sometimes less time consuming could be the other consideration.
Yeah.
Sometimes less expensive could be the, right? There are various reasons which would make you to choose when multiple options are available. Similarly, it depends on the accuracy with which you want to determine, the facility with which you can easily compute, right, and the familiarity with the procedure. All three things are, see, somebody may be very good in writing a program in C language, somebody may be very good in writing the same thing in some other language, in Fortran, let us say, in those days, Fortran, Pascal, C, C++, and we have various other things now. So, the accuracy to which you want to determine sometimes dictates the procedure, the easiness with which you want to compute. See, there are texts which have been composed where the description is, even if you are riding a horse, you will be able to mentally compute eclipses. Understand? It is not an easy thing. It involves lot of computations, but you try to simplify. Accuracy is not that important for me. See, you just told me what is pi value 3.14. That is enough for me. I need not take 1000 decimal places for my purposes, right? Though it may not be accurate, but this is, even 3 is good enough for me. So, that way people have been trying to choose among the procedures, among the values of the parameters involved in the procedures. But I must say, like Modi ji, lekin, he says, no. But the curiosity of the mathematician and astronomer to make it far more accurate is ever driving force. So, people have been devising instruments to make the possibility of having millions of places in pi value. Suppose you have your computer, it can store only up to some number, after that it will go. So, it cannot be determining infinitely correctly. So, you had to devise your own hardware in order to get the value of pi. Why is it needed? Sheer intellectual curiosity. You understand? So, that way people have been devising various procedures to get better and better and better values theoretically. So, whether it has a practical application to that moment. So, suppose you want to know when the tithi ends, whether you want to know up to accurate up to minutes, or you want to know seconds, or you want to know microseconds. How does it matter whether it is 351 or 351.3498 seconds?
I think it's interesting because when I first contemplated the question, I thought the answer would be rather complicated, but it was pretty interesting to know. At the end of the day, we are all trying to simplify complicated things, but the curiosity driving us to be as accurate as possible.
Yeah, even if you are devising the room, for instance,
Yeah.
I want to have, so let us say 8 by 12, okay, 8 feet by 12 feet.
Yeah.
If it is 7 feet 11 inches, okay, and say let us say 0.5, so how does it matter? You are not going to measure to millimeters or micrometers, right?
Yeah.
Mm.
So, how do you think Indian mathematics and astronomy can be introduced into our modern curricula while preserving the historical integrity and mathematical rigor?
Anything that is introduced must have mathematical rigor and historical accuracy. Okay, this should be first of all the most important criteria. So, how do you think, if you ask me this question, I would say the teachers have to learn correctly first. This is the only way. Why should it be introduced is a different question. And if it is introduced, how it has to be introduced is another question. Assuming that you have to introduce, it has to be necessarily introduced historically accurately and with utmost rigor. Otherwise, people will end up making claims, see, which is unsubstantiable, and thereby you will be only bringing some disgrace. Okay. You cannot be claiming something which you have not invented. But if you just say we have known, we have known, we have known, it is wrong. Okay. This will amount to discrediting other culture, other people who have made investigation. But if you introduce accurately, then everyone will be happy. See, nobody wants to brook in ignorance. Nobody wants to be discredited. But there was some attempt to discredit This much we need to know. So, like today, you know that British has stolen away so much. Do you know
Yeah.
how much? Some billions of dollars
Yes.
in today's currency.
Yeah.
Okay. Now, this billions of pounds have been taken away. You need to know. Similarly, you need to know the contribution which has been made and the discredit that has been shown to us also. But you have to be extremely cautious in making these claims. See, there are people who have been claiming that Indians knew heliocentric picture of planetary motion. What do you understand by that? Heliocentric means Earth is also moving around the sun. Do you know Earth is moving around the sun? Yes? Yes, no.
Yes.
How do you know?
Science.
Science told.
Yeah.
Is it possible for you to observe?
No.
No. Then how did they say this? Now, initially, who did this first for the first time? If you see, they will say Copernicus. Understand? Copernicus did not have anything. It was only speculation. Okay, for various considerations he gave. The first observational evidence through a telescope was possible only in 19th century. But people have been studying this heliocentric picture, Kepler's laws of motion. If you are a student of science, you should have studied Kepler's 3 laws, etc., etc. So, these are all only approximations. The question is, without rigor, whether it is possible, not possible. If it has been possible, how was it possible? All things have to be stated very clearly. So, we need to know that we have made phenomenal discoveries, but for that you need to train people, because I lifted this heliocentric because there are many books which keep talking about Indians knew heliocentric motion of planets. This is not correct. The planets are moving around sun is okay, but Earth is moving around the sun, it was not possible. See, they had a picture in which planets move around the sun and the sun itself moves around the Earth. This picture is okay. In the other picture, some people misinterpret. Not only here, in various other domains also, I must tell you. So, therefore, historical accuracy and mathematical rigor is something on which there cannot be any compromise.
I think that was very insightful, and I have to tell you, all the questions from the answers coming from someone as experienced as you, as intellectual as you, one would expect to not understand or might understand very little. But I have to say, the way you told me and everybody watching the answers, I have to say you must be a great professor, and it's our utmost privilege to have you here. And thank you, sir, for giving us your precious time. And thank you for your answers, and thank you for spending time with us in Amrita. Thank you.
Okay, thanks a lot. I appreciate.